Hello students, today we are going to see about the nets of solid. Your best friend's birthday is in near future and you want to gift him something and you want to pack the gift in some special box like this. Many times you may have seen the gift packing boxes, the boxes which are used to pack different items. For example, here a box of a watch. You may say that it's in the form of a cylindrical and a circular cap. One of the box is in the form of a cube with a cap.
Start.
Many times you might be seeing the boxes which are made for packing different items. For example, I have a box which is used to pack the medicines, and you can see that it can be opened easily to put the medicines. So to make such boxes, you should have the knowledge of nets of solid. So let's begin. What is a net of a solid? Net of a solid is nothing but a figure formed by opening the sides of a solid one by one in such a way that the sides will not get separated. Those will be connected with each other and will form a two-dimensional figure on a plain paper. Now let's take an example of this cube. You maybe see that a cube, it's having 6 faces. All the 6 faces are equal and they are square. Now we are going to open this cube one by one. First of all, let's open the top surface. Here the top is open. Then you may see that this is a front, side 1, side 2. Now we are going to open one by one all the faces of this cube. So afterwards we are going to open the front face very carefully. Now front is open, top is open. Now we'll open side 1. Now you can see that this is a base. Front is open, top is open from top, side, front. Now we'll open side 2 and simultaneously back also. So side 2 and back. Now all these are dropped on plane. So front, back, side 2, side 1 and top. All these faces, 6 faces of cube, they are attached to each other and when we fold them, it will form a cube. Now such a figure is known as the net of a square. Now let us take a look at this cuboid, the cuboidal box which is used to pack something. It has 6 rectangular faces: top, front, side 1, side 2, back and the base or bottom. Now if I want to open this, so we will begin with side 1, side 2. To open the front, I am going to cut it so that it will have now front, top, back and the base. So front, side 1, back, top and side 2. When all these are put together and folded, this will make a cuboidal box. Now let us take a square pyramid. The base is square and it has 1, 2, 3, 4 triangular faces which are all joined together at an apex. This is known as apex of pyramid. All these are the slanting sides, 1, 2, 3, 4. All these are in a triangular form and the base is in square form. As the base is square, this is known as square pyramid. If the base is triangular, it's known as a triangular pyramid. In that case, there will be 1, 2 and 3 slanting faces only. If the base is pentagonal, it's known as a pentagonal pyramid and there will be 5 triangular faces. Now we are going to see the example for a square pyramid which is going to have a square base and 4 triangular slanting faces. Now we are going to open one by one all the faces of this square pyramid. So we'll starting with side 1 S1, and here we open the side 1, then side 2, then side 3, and side 4. So you will see that this is nothing but the net of a square pyramid which is having a square base, and the square base is attached with the 4 triangular faces on its 4 sides. Now let us take an example of a hexagonal prism. A prism is nothing but a solid which is having same size of a top and base, and all its sides are rectangle. For example, this is a hexagonal prism, means the base and the top is hexagon and having 1, 2, 3, 4, 5 and 6 rectangular faces, 6 rectangular sides. Let's take an example of a triangular prism which is having triangular top, triangular bottom and 1, 2, 3 rectangular faces. Let us open to know about the net of a triangular prism and a hexagonal prism. As the triangular prism having 1, 2, 3 rectangular faces and 2 triangular sides, so a net of a prism, triangular prism, will have 2 triangular faces and 3 rectangular faces. Let us open. Let's start with the top. Here we open with the top. So I open top triangular face. Now go for the bottom. Bottom is open. Now we will open the sides. So side 1 is put down, side 3 is already there down, and side 3. So the net of a triangular prism have 1, 2, 3 rectangular faces and 2 triangular faces which are attached to one of its rectangle. Now we will dissect a hexagonal prism. So first of all we will open the top. Definitely, as it has a hexagonal top, so and bottom, 2 faces will be hexagons. So first face, which is top open, then we will open the base, Now base is open, so I put down the top base. Now I will open one by one all its sides. So side 1, side 2, side 3, side 4, side 5 and side 6. So net of a hexagonal prism, what I said is a hexagonal prism. Hexagonal prism, a solid shape with a hexagonal top and bottom and 6 rectangular faces. Now it is having 1, 2, 3, 4, 5, 6 rectangular faces, a top and a hexagonal bottom which is attached to one of the face. This is the net of a hexagonal prism. You may have seen your birthday cats which are in the form of a cone, an ice cream cone, which is definitely known as a cone, ice cream cone. You may have been seen. So it's having one curved face and one circular face, which is a flat one and a curved one. So can you guess how many faces this net of a cone can have? Yes, definitely it's going to have a circular face. What will be the another face? This is a curved face. Now let us see and open this curved face so that we'll know how it looked like when it opens. First of all, we will dissect the bottom. After dissecting the bottom, we will open the curved face. So base of a cone is completely in the form of a circle. Now let's open its curved face. When we open the curved face, what do you suppose it will be? Any guesses? Any problems? Here it is. It's a part of a circle. So you'll see that the curved face, when open, it's form a part of a circle. It's a sector of a circle. So the net of a cone is a sector of a circle and a small circle. Now we'll take a net of a cylinder. You may be seeing a cylinder. It has a circular top, circular base and the curved face. So first we will start with the top. We'll dissect the top. We are going to open the faces of solid one by one so that no faces will be completely separated from the given net. If we are having 6 different faces, square faces, in the case of a cube, we cannot make a cube out of it. So all the faces should be attached to each other for a cube. Same as case for a cylinder. So we open the top of a cylinder, which is nothing but a complete circle. Now bottom. When we open the bottom, can you have any guess what it will be? Yes, it's a complete circle. And how will the curved face look like? Any guesses? Any ideas? Let's open the curved face of a cylinder. And a magic, you'll see a rectangle. So curved face, when open, you'll see a rectangle. So net of a cylinder is consisting of a rectangle which will form the curved surface and a circular top and circular bottom. All these three pieces, they are attached together. We have seen one of the net of a cube. Net of a cube have 1, 2, 3, 4, 5, 6 square faces. The first case which we have seen about the net is we open the top, then side 1, side 2, front, back, and the bottom or a base. So we get all the 6 faces which are attached to each other. Will the net of a cube, will this be only possible? No. Let's dissect another cube, starting with the top. Here the top is open. Now we are having side 1, front, side 2, and a base. So one by one we will open front face, then side 1 and side 2. Here the front is open, then side 1 which is attached with the back, side 1. Now we will open the side 2 which is attached with this. So you can see that this is the base, front, we have opened side 1, we have cut open side 2. At the same time the back is disengaged, and here is side 2, top, back, base. So if you can see that all these 6 faces, front, base, side 1, side 2, top, and rear or back, all these are attached to each other, but they are in a different manner, and this is also a possible net of a cube. So we are having 2 possible nets of a cube. In this there is a different arrangement of squares, in this there is a different arrangement of a square. Let us dissect one more cube to find out what type of net does it have. We will again starting with the top. We will dissect top. It's commonly attached with 3 of the faces. So here the top is open. Now we will open. Here we are having front, we are having side 1, side 2, side and a back. Top is attached with the side 1. So first of all we will open side 1. Here the side 1 is open, but side 1 is attached with the back, so it's not easy to open. So we will try to open front. Now front is disengaged. Let's try to disengage side 2. No, side 2 is actually attached with the bottom, and side 1 is attached with the bottom and the base. So we have to go for a downside, where the side 1 is attached with the side with the base. Let's disengage this. One more attachment, we will find that the back and the base, they are attached with each other. So as you can see, as we open now, in this case, 6 square faces, 1 2 3 4 5 6, they are attached in different manners. So in front we are having different possible nets of a cube, so in which there is one arrangement of this. In second, all the 1 2 3 4 faces are attached to each other with side 1 and side 2. In third arrangement, we are having sides which are attached to back, a base and a front attached to each other with one side and a top attached to each other. All these possible nets of a square. We have seen one type of a pyramid, a square pyramid, in which we dissect all its sides and we find that net of a square pyramid is having a square base, side 1 2 3 4 which are attached to each other. When they are folded, they will form a pyramid like this. So I am having one more pyramid with me. Let's dissect this and we'll find whether this pyramid is going to have same net as first one. So starting with side 1, we will dissect side 1. As we open the side, we'll find that the side is attached with base, so I'm going to detach it from the base. So side 1 is open. Now we are having side 2. So side 1, it's in the form of a triangle. Side 1 and 2, they are attached with H. Side 2 is disengaged. Now you can see that side 1 and 2 are attached with side 3. Side 2 and 3 are attached with a single H. Side 3 is attached with a base. So I am disengaging it from base, and at the end you can see that side 3 is attached with side 4 with a single H, and side 4 is attached with the base with a common H. So this is a possible net of a pyramid where a square base or a bottom is attached with one of the triangular face, and the triangular faces are attached with other triangular faces with a common H. So these are the two possible nets of a square pyramid. Possible nets of a square pyramid: 1, square bottom which are attached individually to all this triangular sides, and in another case the triangular sides are attached to each other with a single edge and one triangular side is attached with a base. Now let us see how to identify whether the given figure is a proper net or not. We're starting with a square, so with a net of a cube. So suppose a figure is given which is having 1 2 3 4 and 5 squares. Is it a net of a cube? Remember that the net of a cube has having 6 square faces. So we need 6 squares to complete a cube. Can I put a square over here? Is it possible? Let's try to fold this. If I suppose that this is a base, this is a side 1, side 2. If I fold these two and then try to fold it like this, then you'll find that this and this face these two will form the front face and overlap to each other, and this will form the back, and this particular figure or solid will not have the top. So we will rearrange it. Let's try to put a square overhead. Now this will form the base, a side 1 which will be folded like this, side 2 which will be folded like this. This will form a back. Now, if I fold like this, this will form a front face, a front. And now this will definitely cover the cube and this will form a top. So this is a possible net of a cube. One more example that I am giving. One, two, three, four, 5 and 6. We are having 6 squares over here. Can it be folded to a cube? Let's try. Fold this front. Let's make this as a base. We will going to fold this, so this will form a front. We are going to fold this so that this will become a back. We will fold this like this and this like this, and then it will be folded like this. So they are both forming side 1 and this will form side 2, and this figure does not have a top. So this is not a possible net of a cube. One more example we will see. 1, 2, 3, 4. Now, in this figure, we are having 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 squares. Will it form a cube? Definitely, this will form a cube, but this side will overlap. For example, if we are starting with this, and this will form a base, this will form a front, this will form a back. But when we fold these two squares, this will form a common side 2. This will form a side 1. This will form a top. Again, these squares are going to overlap what are the sides present in the particular cube. So this is also not a possible net of a